Something doesn't make sense on Wall Street right now, and if you blink, you'll miss what it actually means. Companies like IBM, ServiceNow, solid names, reliable earners, they report their quarterly results, revenue is up, margins are holding, they beat analyst expectations. And their stocks collapse, not a small dip, not a correction, billions wiped out in hours for doing everything right. That is not normal market behavior. That is a signal. And if you know how to read it, it doesn't just tell you what's happening to software stocks. It tells you what's coming for energy systems, for infrastructure, for green hydrogen. Because the force that just broke the software business model, it's moving upstream. And the next system in its path may not be ready. To understand what's happening, you need to go back about 30 years. The software industry was built on one of the cleanest business models ever invented. Build a tool once, charge every user who needs it. As companies grow and hire more people, revenue scales automatically. No factories, no raw materials, no physical constraints. It was elegant, it was scalable, and for decades it worked. Customer relationship platforms, analytics dashboards, HR systems, workflow tools, project management software. The entire category exploded because every employee in every company represented a potential license. But here's what's happening now. AI doesn't just improve those tools, it replaces the need for them entirely. When a single AI system can perform the work of 10 employees, you don't need 10 software licenses anymore. You don't even need the same categories of software. Customer service platforms become redundant when AI handles the tickets. Analytics dashboards become unnecessary when AI surfaces the insight directly. Workflow tools disappear when AI manages the process itself. The software wasn't bad, the model just became obsolete overnight. And that's what investors are reacting to. Not quarterly performance, not earnings misses, but extinction risk. Because for the first time in 30 years, the fundamental assumption behind the software industry, that more employees equals more revenue, no longer holds. And markets don't wait for confirmation, they price in the future. So the question is, where does that force go next? Here's where this stops being a tech story and starts becoming an infrastructure problem. Because AI doesn't just replace software, it replaces it with energy demand. Every AI query has a physical cost. Training a large language model requires enormous compute power, sustained, concentrated, and often running continuously. Running inference at scale means data centers operating around the clock. Cooling those systems requires additional energy on top. Then there's redundancy infrastructure, backup power, and network load. Multiply that by the number of AI systems being deployed globally right now, across industries, across borders, across use cases, and the numbers become almost uncomfortable to say out loud. Data center energy demand is growing at a pace we haven't seen in the internet era. Some projections suggest AI-driven electricity consumption could double global data center load within this decade. And that creates a very specific problem. Because the world made a commitment to meet that growth, all of that demand, with clean energy. Not fossil fuel backup, not temporary solutions. Clean, reliable, scalable power. And right now, the gap between that commitment and the physical reality is enormous. So the question shifts. It's no longer just, what does AI replace? The real question, and the one that determines the next decade of energy investment, is what powers AI? This is where green hydrogen enters the picture. Not as a buzzword, not as a political promise, but as a proposed system-level solution to a real physical problem. And on paper, the case is strong. Green hydrogen offers something that most clean energy technologies don't: the ability to decouple energy production from energy consumption. Solar and wind produce power when conditions allow. Green hydrogen allows you to store that energy at scale over time and deploy it when it's actually needed. For a world where AI demand is volatile, spiky, and geographically concentrated, that flexibility sounds like exactly what the system needs. Long-duration storage, grid stabilization, industrial decarbonization, flexible dispatch. The theory is clean, the chemistry works. We've known how to split water using electrolysis for over a century. But here's where the theory meets the system. Because the same stress test that just broke software is now being applied to green hydrogen. And under pressure, the weaknesses start to show. Green hydrogen doesn't fail at the technology level. Electrolyzers work, the electrochemistry is sound, the output is real. The failure happens at the system level. And the most critical point of failure is utilization. Most green hydrogen economic models are built on an assumption. that electrolyzers run at high capacity, 60, 70, sometimes 80% of available hours. That assumption is what makes the cost per kilogram competitive with fossil-based alternatives. But real-world conditions don't cooperate. Renewable energy is intermittent. Grid constraints limit access. Curtailment reduces runtime. Permitting delays push back commissioning. Off-take agreements fall through. And suddenly, your utilization rate doesn't hit 70%. It hits 40, sometimes less. Here's why that matters. Green hydrogen cost is brutally sensitive to utilization. Drop from 70% to 40%. And your cost per kilogram doesn't increase marginally. It can double, sometimes more. Before you even account for financing costs, storage losses, compression, transport infrastructure, or grid interconnection fees. This is not a marginal issue, it is structural. And most models quietly assume it away. Because if you need high utilization to make the economics work, and real-world conditions make high utilization nearly impossible to guarantee, you don't have a technology problem. You have a system design problem. And that distinction matters more than almost anything else in this space. Now layer in the ESG constraint, because there's a filter that rarely shows up in hydrogen project analyses, and it's already active. Institutional capital is no longer just chasing returns. It's screening for water intensity, grid carbon exposure, and Scope 2 emissions. A green hydrogen project that strains local water systems, because electrolysis requires purified water in regions where data center expansion is already competing for the same resource, doesn't just underperform financially. It fails ESG screening before it ever reaches investment committee. A project dependent on a high-carbon grid doesn't produce genuinely green hydrogen. It produces greenwashing. And sophisticated capital allocators know the difference. That's not a future risk. That filter is already active. And it's already killing projects before they're even announced. Here's where it gets uncomfortable, because now we need to put both forces in the same frame. AI is driving exponential energy demand. Green hydrogen is offering long-term, flexible, clean energy storage. But the system connecting them, the infrastructure, the grid architecture, the financing structures, the regulatory frameworks, is not ready. And that mismatch is the real story. Because AI doesn't demand energy the way a factory does. A factory has predictable load profiles, consistent draw, manageable variability. AI data centers don't work that way. They scale dynamically, they require burst capacity, they prioritize uptime above all else. A major model training run can spike demand in ways that no traditional energy procurement model was built to handle. Green hydrogen thrives in systems where energy can be produced, stored, and dispatched flexibly over time. It's a system built for patience. AI demands immediacy, not stored potential, not flexible dispatch windows. Instant, reliable power, now. So the mismatch isn't just technical, it's temporal, it's operational, it's structural, and that creates a collision. Look at what's already happening in practice. Data centers are clustering around regions with stable, reliable grid access, not necessarily regions with renewable abundance, not hydrogen infrastructure hubs, just reliability, because downtime is unacceptable. And in many cases, that means fossil-based backup systems are still in play. Diesel generators running alongside solar arrays, natural gas peakers supporting AI campuses. Not because operators want this, but because under stress, systems fall back to what's proven. Even as AI pushes energy demand to levels we've never seen before, the infrastructure beneath it is regressing. And green hydrogen isn't filling that gap. Not yet. Because if this doesn't work, it's not just hydrogen that fails, it's the entire idea that clean energy can scale without breaking the system. The assumption that renewable storage can absorb intermittency at scale, that green molecules can replace fossil fuels in hard-to-abate sectors, that the energy transition doesn't require a trade-off between reliability and decarbonization. That assumption is now being stress-tested in real time. Billions of dollars have been committed. Projects announced across Europe, the Middle East, Australia, the Americas. Policy frameworks aligned, targets set. But very few have reached final investment decision, and even fewer are operational at scale. Not because the vision is wrong, but because the system isn't complete. You need cheap, consistent, renewable power, high utilization, secured offtake agreements, storage and transport infrastructure, regulatory clarity, financing structures that can absorb volatility. Miss one of these, the project stalls. Miss two, it collapses. And that's before AI enters the equation and changes the entire demand profile around it. So what does survival look like from here? It means we are entering a phase where performance is no longer enough. Survival for software companies, for hydrogen projects, for energy infrastructure, depends on system alignment. The companies that succeed won't be the ones with the best technology. They'll be the ones that can operate under real-world constraints. Variability, financing pressure, regulatory friction, ESG scrutiny, demand uncertainty. For green hydrogen, that means focusing on environments where the system is already partially aligned. Industrial ports, petrochemical hubs, regions with existing infrastructure and captive industrial demand. Places where utilization can be stabilized through integrated committed offtake. Not speculative markets or isolated projects that exist only on spreadsheets and policy papers. For AI infrastructure, it means confronting the physical limits of exponential growth. Energy availability, cooling capacity, water access, grid headroom. Because demand doesn't exist in a vacuum, it exists in a physical system that has hard limits. And for investors and developers, it means changing the question you ask. Not, does this technology work? But, does this system survive under pressure? Because that's the question markets are now asking. It's the question that just ended the software era as we knew it. And it's the question that will determine what gets built in energy and what gets abandoned. This is exactly why we built H2 Hub by ReneEnergy. Because the next phase of hydrogen isn't about announcements, it's about execution. How projects actually reach financial close. How systems are stress tested before capital is committed. How utilization assumptions get challenged against real grid data, real offtake structures, and real financing terms. If you're serious about operating at that level, as a developer, consultant, or investor, the link is in the description. And if you want to go deeper into the execution layer, financial models, utilization sensitivity analysis, real-world project assumptions, those tools are linked below. Because in this environment, clarity isn't optional, it's your edge. AI is rewriting the rules of software, but it's also exposing the limits of the systems beneath it. Green hydrogen is now stepping into that same test. The technology already works. The system decides who survives.